Colby, math.com.
Okay, we're plotting ordered pairs on the coordinate plane on this assignment, and I'm hoping that the discussion of problem 14 will help you with some of the other problems. We're plotting these points, these four ordered pairs, A, B, C, and D. Point A is at -3, -1, so first we need to remember that it's called an ordered pair because the coordinates are given in order, x followed by y, your horizontal coordinate first and your y coordinate second. We always start at the origin, that's why it's called the origin, it's a starting point. And if my x, my horizontal coordinate, is -3, we move 1, 2, 3 to the left. The y coordinate, the vertical coordinate, is -1, so we move 1 down. And so point A is located right here in quadrant 4. Now, we talked about how to number the quadrants. If you're making the capital C, which could stand for a coordinate plane, you start in quadrant 1, you move through quadrant 2, you're making your capital C, you naturally move through quadrant 3, and you end in quadrant 4 to make a capital C. And so the numbering of the quadrants, if you just remember that C, you'll remember that this is quadrant 3. 1, 2, 3. B is at 0, 4. If the x coordinate is 0, and when we start at the origin, we don't move for x. We don't move in any kind of horizontal right or left direction. But y is positive 4, so we do need to move in a positive vertical direction, or up 4. So point B is right here, and the instructions for this problem tell us to connect that point to the previous point. That's the same thing you did when you're graphing the cartoon character. You connect each point to the previous point until you hit stop, and then you stop that dot to dot, and then you start a new dot to dot where it says start. Hopefully we had time to go over that in class. I'm sure we probably did. Point C is at, and the location of point B, it's not in a quadrant, it's on an axis. It's on the y-axis. It's in between quadrants 1 and 2. It's on an axis. Point C is at 4, 3. So I start at the origin always. My x-coordinate is positive 4, so 4 to the right. Y-coordinate is positive 3, so up 3. So point C is right here in the first quadrant. And point D is positive 1, -2. So I start at the origin and I go in the positive 1 direction for x, or 1 to the right, and the -2 direction for y, which is 2 down. So point D is in quadrant 4, connected to C, and then connect D to A, it says here at the end, and then name the figure. Well, this figure has, it's a polygon with 4 sides, so it's a quadrilateral, but it's a special kind of quadrilateral because these opposite sides are parallel and congruent, and these opposite sides are also parallel and congruent. And if you have a quadrilateral with 2 pairs of parallel and congruent opposite sides, it's a parallelogram. Now the harder part of this problem is finding the area. I used to do this, well, first of all, let's just think about the area of a parallelogram. It's base times height. However, you know, if I use this as my base, it's difficult to know how long that is. If you see a right triangle here, you're correct, and you could calculate the hypotenuse, but because this is not a Pythagorean triple, we're not going to get a nice hypotenuse, we're going to get an irrational number. And so it gets really tricky to directly calculate the area of this parallelogram. What I used to do was break this parallelogram up into right triangles. You see one of them here, and you see another one here. And I used to do an additive method where I break up the right triangle into pieces where I could calculate the area of each piece and add them all together. But then my student Alan taught me a better method I want to share with you. If we draw a figure around the parallelogram in this way, just think about what that figure is. It looks like a square at first, but if you count the base, 1, 2, 3, 4, 5, 6, 7. It has a base of 7 and a height of 1, 2, 3, 4, 5, 6, height of 6. So it's a rectangle, a 7 by 6 rectangle. And so we can use that 7 by 6 rectangle to find the area of the parallelogram, because these pieces are right triangles and they're easy to calculate. And so this is a subtraction method, and we did things similar to this when we did composite area. It's kind of like, it's very difficult to find the area of this parallelogram. It's kind of like sculpting a statue. Making a statue is easy. Like if you wanted to make a big statue of Mr. Colby, you take a big rectangular prism of marble, and then you just chip away all the pieces that don't look like Mr. Colby. So it's easy. You just chip away these right triangles because they're easy to calculate, and we'll be left with the parallelogram that's difficult to calculate. So you should be able to calculate the area of these triangles and use that to find the area of the parallelogram. Do that during the pause and then come back and see how you did.
Paused.
This area of this parallelogram is going to be equal to the area of the big blue rectangle, which we've already identified as a 7 by 6 rectangle, minus the area of all of the triangles, all these blue triangles. With it, I want to number the blue triangles, so let me number them. 1, 2, 3, and 4. And you see that triangle 1 is a 3 by 5 rectangle. Triangle 2 is a 3 by 5. Triangle. 3 by 5 triangle. Triangle 2 is a 3 by 5 triangle. The area of triangle 1 is equal to the area of triangle 2. Area of triangle 1 is 1/2 base times height, or 1/2 3 times 5. And that's not nice because neither of these factors are easy to have, and neither is the product. However, if we're eventually going to add A1 plus A2, and A1 and A2 are congruent, then I'm just adding these two halves. So I can just get rid of the half. Half of 3 times 5 plus half of 3 times 5 is just 3 times 5. Or you could imagine putting these two triangles 1 and 2 together to make one 3 by 5 rectangle. So ultimately we're going to subtract A1 plus A2 plus A3 plus A4, the sum of all of those 4 right triangles. A3 equals A4, and these are smaller. They're a base of 1 and a height of 1, 2, 3, 4. So A3 equals 1/2 of 1 times 4. But again, if we're going to add A3 plus A4, that's just half of 1 times 4 plus half of 1 times 4 is just 1 times 4, or 4. And so A1 plus A2 is 3 times 5, which is 15. A3 plus A4 is 4. And so when we subtract the triangles from the rectangle, which is an area of 42, we get 42 minus 19. When I subtract 19 from 42, I just subtract 20 from 42, because that's easy to subtract, and I get 22. And then I just realized that I subtracted 1 more than I should have, so I compensate by adding 1, and the difference is 23. The area of the parallelogram is 23, and we weren't given any units, so we'll say units squared. Okay, I hope that helped with the assignment. I'll see you tomorrow.